N is for networking, where today we have a very special episode. We are going to read through several comments of, feedback that we've gotten from folks over the last several months. We're going to cover topics related to tunneling, link aggregation control protocol and link aggregation in general, and DHCP options. I'm Ethan Banks, along with Holly Metlitsky. And Holly, you've been posting on LinkedIn quite a bit, where I post as well. You can follow us on LinkedIn. That's the best place to keep up with us. Holly, you've been posting about certifications that you've been doing. You're a Juniper employee. You work on the sales side of the house. You've been doing a bunch of Juniper certs. Tell us the latest.
Sure. So I went to our annual technical summit, and why this is important is the last few years, they haven't done in-person testing. So I've never actually taken a cert in person before last week. All of my certs
You mean you did it from home, like, the remote thing with the webcams on you and the proctor going, I saw you try to,
yeah. It's like, you're resting on your hand, move your head back into the frame. I'm like, well, come on. So that was a new experience for me, which is funny because your whole life you test in person and then suddenly things change, and I got really used to like being proctored at home in my very quiet, confined space with my white walls and zero distractions. So we had in-person testing. It's, free certification testing for Juniper people. So I thought, let me just try a couple, see how they go. As I've mentioned previously, I've been working towards my JNCIP Enterprise. So that's
the middle tier of the ladder. Like you've got there's the associate level, there's professional, and there's expert.
Juniper has 4.
Okay.
So Juniper's got associate, specialist, professional, and expert.
Gotcha.
So one away from a JNCIE on paper. But my plan wasn't really to actually pass the cert because I was prepping for it, but this was too soon on my timeline. I knew that my goal for the certification was to understand the content fundamentally, not just to pass the cert. So I thought, it's free trials internally. I'll give it a bash. Mm-hmm. I gave it a bash. I got off the plane. I was like, let me do it. I failed. Mm-hmm. As things go.
Failed spectacularly, or were you kind of close?
No, actually. I think the passing requirement was 62%, and I got 55. So I was like a couple questions off.
You can see it from there, yeah.
So I was like, you know what? I'm going to try again. That was the Monday. I should have done some prep for my retrial. I didn't do much prep. I read some day one books, which I actually highly recommend. They're very short, interesting.
I recommend them too. Yeah. I'm very familiar with the Juniper Day One stuff. Great publications. Mm-hmm. Usually not that many pages, but lots of very practical hands-on how to get X done.
Yeah. And I never actually read a Day One book before. This is my first. I'm not sure why. I just hadn't bumped into them. A colleague of mine was like, read the Day One multicast book. It's great. I'm like, okay, 20 pages. Super great, all the fundamentals, amazing. So I passed it on my second attempt, but yes, I have the cert, but I haven't actually reached my goal because my goal was to fundamentally understand all the content. Like I want to come out of it and be a professional professional level in routing and switching.
So you're a JNCIP Enterprise. You did pass.
Yes.
Was that just one exam or?
Just one exam, yes.
Okay, so that's one exam. You have your JNCIA. You have, I believe, right? And then you've got a bunch of specialist certs as well, like 8 of them or something crazy.
Yeah, I've got a bunch. I now have 10 certs in total.
Okay, and now you've added JNCIP, but you're not happy.
No, I'm not. Because I just don't feel validated in what I know. Like, I know that I can pass the cert, but I haven't had hands-on experience with a lot of the topics that are in that cert. And I just feel, I don't want to say I feel like a fraud because that's a terrible thing to say. I don't. I know a lot of the content. I just don't know all 45 modules, And I want to know them and I want to know them well. So that's my next plan.
I'll give you my take on some of that for what it's worth. So I did a bunch of certs over the years, and up to CCIE. I finished the Cisco's expert level cert many years back. And And there's some amount of knowledge in those different exams that I took where I've never done whatever it was in real life, this thing that they wanted me to know. I've never had to apply this technology in production. Done it in the lab? Sure. Do I understand the concepts? Yeah. For example, multicast. I've never run a multicast network in production. Can I make it work in the lab? Sure. Do I understand the concepts? Don't ask me today, but there was a time that I understood reasonably well. I'd have to do a lot of reviewing to get back my multicast chops. And I think on some level that's normal, where the cert will expose you to some technology that you've not used in production, because not every network's going to run multicast. It's kind of a specialized thing, just picking on that one as an example.
Well, I was going to say that was the one that I was like, I really want to know more about it, but I haven't run into it at all. So I've got a bit of knowledge about it, but if you ask me to come troubleshoot your multicast network, I wouldn't recommend asking me, because I've never done that.
There's certain verticals that do get into it. High frequency trading, for example, there's multicast feeds that are involved there. I know broadcast media, they will often use multicast to be distributing video feeds, for example, out and about. So it comes up, but most shops don't use it except in like we were talking about OSPF in the weeks before this show, and it comes up. You're sending a multicast of OSPF hellos out the door to 224.0.0.5 and 6 or whatever they were. I've already forgotten, but I think that's right. But that's not building a multicast tree, and that's not understanding PIM, sparse mode, dense mode, or some of the newer stuff like BIER, BIER. I don't know if that came up in your day one book or not, but I know that's a related technology that sometimes comes up in multicast conversations and so on. But
the thing is, before I started doing the cert, you would have thrown those acronyms at me and I would have been so lost. You're now throwing those acronyms at me and I can place them. I know what they are. I understand their use cases. Like, I can enter a conversation about all this stuff much better than I could before. And that's awesome. Like, it's like the first step. But maybe it's also just like my personality type. Like, if I do something, I want to be 110% at it. But I guess to be a expert in every single protocol, every feature, every little nitbit of all switching and routing might be a bit of a tall goal.
Well, there's a balance to be found there. If you don't run a certain technology in production, no matter how deep the cert goes, there are elements that you just won't, little nuances and tricks and gotchas and design characteristics and so on that, they're not going to sink into your head. If you've been there, you've run it, as I like to say, in anger, you're just going to learn some of that stuff that from a lab perspective, you kind of won't. Now, but you do, I'm with you. I also want to know the technology well enough that I can walk into a situation and be pretty confident about what I'm talking about. And I've done enough stupid lab stuff that even though I haven't run it in anger, I feel pretty good about it. And I don't know where that line is. You kind of get to a point where you're like, I'm feeling all right. I don't know that I ever got there with multicast, honestly, because honestly, at the time I was learning multicast for CCIE as it happened, the code was so buggy that to do labs, there'd be instructions by the people that created the lab, like, if you're doing this and you type this in and it doesn't work, actually just restart your router. It'll probably be fine when it comes back up. Like, really? So I mean, that was kind of the world we were in at that time. So I don't know where you find the balance. I'm with you. You probably don't know it as well as you want, and will feel better when you get a better handle on it, which will take what, by the way? How are you going to get there for multicast and whatever other topics are bothering you?
Well, I think the first thing is I need to lab a lot of it. So again, my purpose wasn't to pass the cert now. It was to pass it like in 3 months from now. So like, I didn't get done everything I wanted in order to prep for the cert.
So you were doing recon is what you were really doing. You had no expectation that you were actually going to pass the thing. It just
absolutely
worked out.
Not. I was like, I'm going to give it an attempt. I'm probably going to like get 20% for it. And then I'm going to feel great because that was my plan. But then it was 55 and it was in reach. And I was like, you know what? I can get there. Can I get there well? maybe not, but I can get there. So it's like, it's almost like mentally I haven't passed the cert because I haven't like, and again, I wasn't doing the cert for the cert. I was happy to do all of the content and never even take the certification.
Yeah.
Which maybe that's the part of it. It's like, I really wanted to learn more, and I think I did, and I have, but there's still so much. There's still so much to know. Like, there's so many labs to do. It's just, it's never enough.
You're highlighting something else that's really important, which is there are people that want the cert for the cert because they have to have it. They work for a vendor partner, and that vendor partner requires you to maintain your partnership. You have to have X number of certified people on staff. And so your boss is like, I don't care what it takes, just pass the stupid thing. Yeah. They're not there because they want to know all the things. They're there to literally to pass the exam because it matters to the company that they work for. And there are those people who are more like you and more like me. I want to know the stuff, and certification just provides me a framework to show me all the stuff that the vendor thinks I'm supposed to know and give me a map so that I can learn all these things. And I'm going to do the reading, and I'm going to do the labs, and I'm going to know this stuff. And when I walk into that exam, I don't want to just barely pass it. I want to crush it. And I'm going to be irritated by the things I get wrong. And then I'm going to look those up and see if I can figure that out, because that's a different thing. You're turning yourself into a network engineer. That's what it takes.
And like, I want to read a question in a cert, and like some of them are a bit weird and they have like little idiosyncrasies. Like, I want to look at the question. I want to be like, yeah, seen this. I know what they're getting at. Like, this is obviously the answer. Like, no questions asked. No, like, oh, well, they've given me this and this is kind of similar. Like, I just want it to be a no-brainer. But I don't know. I've got 2 years of network experience. I think I'm a little bit ahead of myself in what I should be doing, which is typical for me. But like, you know, my plan is now to go and do all the labs, spend more time on the sections that I don't know as well, and just really like continue to hone in on, I think specifically routing and switching. I think that's where I'd like to focus for now. Like, the data center is always there, and like, it's like my secret passion. But like, I truly believe, like, I could have gone and done the data center certification, but I felt like that builds upon the basics of routing and switching. And someone asked me about this. They're like, oh, I'm thinking of doing a cert. Which one do you recommend? I'm like, you could do the data center. It's less content. But if you don't fundamentally understand all of these routing protocols and layer 2 stuff, cool, you can learn about EVP and VXLAN and you can answer the questions. But again, you're not understanding the fundamentals of what it's built on. So that's what I'm trying to do.
Which is why we've structured this show, this podcast, the way we have. It's like, well, you know, because we've had people ask us, I want you guys to talk about EVP and VXLAN. It's like, well, yeah, but there's so many technologies that is built upon that we've got to talk about those other technologies first so that we can refer back to them when we do get to the EVP and VXLAN discussion.
100%. And I did it backwards.
We're not there yet.
No, we're not. And I did it the wrong way, because maybe I didn't do the wrong way. Like, I understand EVP and VXLAN somewhat. However, going through my JNCIP, we now start talking about route reflectors in terms of BGP. I never actually did that in my lower level certs because that's quite technical. So I went straight into route reflectors in the context of deploying an EVP and VXLAN. And I was like, cool. Great. I don't know where these come from. Yep. This is fun.
Here, jump into the deep end of the pool. I'm going to throw you this concrete block to hold on to while you're trying to swim.
Exactly. And now, like, I've taken 10 steps back. I'm like, oh, I get it. Now I can, you know. So we'll see.
You're putting all the pieces together. Like you said, you're doing it kind of in reverse order, but it's happening.
It's helped. Like, the reverse order kind of works because I've got context that I guess shouldn't really have, but I've got the context to be like, oh, I remember this, didn't really understand it, but now I do, and I understand how it fits in, and like, I'm really enjoying that. Like, I had a lot of aha moments going through my JNCIP where I was like, oh, I had a customer with this issue and this layer 2 and authentication and this, and this. I'm like, here it is. I've done this. I didn't know what I was doing, troubleshooting the customer's situation then. I got it correct, and like, I figured it out, obviously, because you can figure it out. But now I'm like, I actually understand the fundamentals of it, and that's really cool. I can go back and be like, oh, this is like exactly what I did. This is why it was right. I could have not done this, and it's cool to see like my brain growing, I guess.
One more comment before we get to our listener questions. We're getting
Mm-hmm.
there. We promise. We got your questions. So it's all on a doc right in front of us. But you mentioned, I feel like I'm going too fast. I've only got 2 years into this. You can learn a ton of information if you have the time in your life to spend with books and labs and all of that stuff and take it in. The shortcoming of only having 2 years of experience right now is that hands-on real world where there's things you got to see blow up on production networks and then add that brick to your knowledge wall. That's probably a terrible analogy, but you see what I'm trying to say.
Yeah.
Your knowledge building, your knowledge ziggurat, a pyramid. There we go. Okay, I'm trying too hard. But you add that bit of knowledge in to understand weird things, quirky things to look out for that you only see in production because production networks are weird. There's unusual things that you don't think of or don't consider that just don't show up in a lab because the labs are, especially when you're doing a lab that's designed to teach you where it's very sanitary. You're going to do this and these two routers. You're going to configure with these commands, and then they're going to appear, and there'll be OSPF neighbors, and it'll be
everything
wonderful.
works.
Everything works, and then it's the production stuff where stuff doesn't work that you end up with some of those battle scars that add to your knowledge base and come back up as a red flag in your mind when 3 years later you're sitting in front of a customer account in your case, let's say, and they want to do X and you're like, you probably don't want to do that like that for this reason. Or you want to make sure you have this element in the design because that'll help prevent this problem that I once experienced. Ask me about that very bad day I had in the data center, kind of thing. That's the only shortcoming. I wouldn't be intimidated by the short time frame other than that, because you're at this point in your life where you got some time and the luxury of being able to do it. So, man, don't be intimidated just because your experience timeline-wise is short. Go for it.
I think I just want more from myself. Like, why can't I just know everything today? You know, it's like take your brain, put it with my brain, transfer of knowledge. You know, there'll be some gaps, I'm sure. We've got a multicast problem, it seems, between the two of us, but we can figure it out. You know, I'll know what to focus on then.
But I've been doing this stuff since 1995. So, I mean, I got 30 years on you.
I don't have 30 years to learn this stuff. Like, I want it tomorrow. Or yesterday, actually.
I hear you. And I too was similarly impatient. Well, all right. Let's get to some listener questions.
Yes.
So, first one is on tunneling. Lewis submitted this one, and Lewis says, "Great work on the podcast, Holly and Ethan. Thank you for saying so. Always enjoy listening to you discuss these fundamental topics. I've just listened to Tunneling Quirks and Features and wanted to specifically comment on PMTUD for UDP. So this is looking at a packetization layer path MTU discovery, PLMP. Some things
actually don't need acronyms. Like
that is a terribly long acronym.
I saw that acronym. Like I think that's the longest one I've seen in networking so far.
PMTUD, Path MTU Discovery it was the acronym, and then the packetization layer component got added to it, and so it had to become PMTUD. So on. And anyway, Lewis just wanted to point something out for us because we didn't get into the nuts and bolts of exactly the mechanism for how that worked. We hadn't looked it up exactly. And Lewis is shedding light on this and says, just like in VXLAN, where you're relying on the higher level of abstraction, in that case, the TCP packets encapsulated in the UDP VXLAN packets, it's no different with PMTUD for UDP. The issue that we were not kicking around is like, well, UDP is not an acknowledged protocol. So if we don't get something back, how are we measuring path MTU if there's nothing coming back because there's no acknowledgement mechanism? What's happening? And so, okay, this is what Lewis is explaining. It's no different with PMTUD for UDP, where you're relying on a higher level of abstraction. In this case, it's the software algorithms in the devices implementing PMTUD that's responsible for sending acknowledgments. It's just using UDP as the transport protocol, and all acknowledgments are initiated from the software stack. And he's making that VXLAN comparison by saying, well, hey, VXLAN is UDP. We're not relying on VXLAN packets to be reliable. We're expecting the packets inside of VXLAN, it's TCP. It's a TCP packet being tunneled inside of the VXLAN packet. We're expecting that to be reliable, and so we don't need the higher level protocol to be reliable, to be acknowledged in that way. Does that jive with your thinking, Holly?
Yeah, it was interesting because, again, longest acronym I've ever seen, and something that I haven't run into and actually haven't come across in any of my certs. So it's always interesting, we discuss these topics at a very high level, and I love seeing the little details that people think of and comment on, and I learn a lot from the feedback as well.
To accent a little bit more on what Lewis is saying here, I did a little digging into the IETF. We've talked on this show about IETF, Internet Engineering Task Force documents. They publish RFCs, request for comments. There are thousands of them. RFC 4821 in section 10.4 talks about the probing method using applications. This whole RFC is about packetization layer path MTU discovery. And so if you dig through RFC 4821, they're free, they're on the internet, just go Google RFC 4821, you can read this for yourself. Section 10.4 says, quote, the disadvantages of relying on IP fragmentation, we didn't talk about fragmentation here, but we're talking about conceptually the same issue at hand. The disadvantages of relying on IP fragmentation and an adjunct protocol to perform path MTU discovery can be overcome by implementing path MTU discovery within the application itself using the application's own protocol. The application must have some suitable method for generating probes and have an accurate and timely mechanism to determine whether the probes were lost. Ideally, the application protocol includes a lightweight echo function that confirms message delivery. That is IETF speak for basically what Lewis was describing for us. And the point about fragmentation is, when you were dealing with maximum transmission unit size, and you want to know how big of a packet you can shove through a particular interface based on its maximum transmission unit size, if you can't fit it through, you might fragment it. That would be the solution. And so one way to detect, I hit MTU, look, I'm dealing with fragments on the other end. But if you can't rely on that, or don't want to rely on that, what RFC 4821 section 10.4 is saying is, bake it into the application itself, like use an echo function, which is what a ping is. A ping is an echo, an ICMP echo.
One thing that I think is kind of important to comment on is, why is it important to have specific probes or testing for MTU? And again, going back to my certs and whatever, my learnings, every single module at the end has a troubleshooting, methodology, and every single one starts with check MTU. Mm-hmm. So it's a common problem that you may face. So why not proactively make sure it's doing the right thing? Save you some headache, hopefully.
Yeah, fragmentation is an annoying problem. It's a performance challenge. There's the router on the other end receiving the fragments after the packet's been fragmented, has to reassemble them. Fragments can increase the chance of something being lost. And so if you get a fragment of a packet and not the other fragment or fragments, you've lost all of it, essentially. You got to retransmit the whole thing, etc. Yeah, so I'm with you. You definitely want to know your maximum transmission unit along a given path and size your packets appropriately along the way, making adjustments as you can, which could be a whole episode unto itself, it came up in the tunneling episode that Lewis was referring to, although we didn't spend tons of time on it, but there's lots of mechanisms for controlling that, and not just within the networking switches and routers that people like you and I might be working on, Holly, but also you can do that at an operating system level. There's ways to tweak that stuff, like within Windows and Mac OS and Linux and so on. All right, we ready for the next question?
Yep.
or comment. Okay, Michael says, as a former networking instructor, I'm all about finding the right analogy, and he's got a great analogy here. Actually, there was some back and forth about how the tunnel analogy breaks down quickly, because we were talking about like, well, it's like taking a box and putting it in another box, and we have all these different ways we're trying to describe how a tunnel works. So here's what Michael says. During the episode, I was racking my brain on a better analogy, and I landed on ferry. Ferry as in something that would carry cargo from one shore to another shore. He continues, the internet/untrusted network are shark-infested waters, and the car, packet frame, can traverse safer across the water. That is, the car goes on the ferry goes across the water. Michael continues, and if that ferry was enclosed, then the car on the inside would only see the drive onto the ferry. Quote, that would be encapsulation. And the drive off the ferry would be decapsulation. He says, I'm sure there are other better analogies out there, but I had to share my thoughts in case they help. While I already understand many of the topics on NS for Networking, I'm enjoying the back to basics nature of the show, and keep up the great work. And we will. And I like your ferry analogy, Michael. That works for me. You're nodding, Holly. You
I like it
too?
a lot. Yeah.
Yeah. I thought that was a good one.
It just removes everything related to tunnels. So I'm very happy about it because, I had some choice thoughts on tunnels. So I like the ferry.
I was just going to say, I remember that episode now, and tunnels upset you a great deal.
They did. So we can stick to boats.
Okay. All right. So that's our first section. We had those comments on tunneling. Our next section here is about link aggregation. And we got 3 messages, and I think a few more that might have snuck into my DMs that I didn't track them down. By the way, the best way to send us these sorts of follow-up messages is via packetpushers.net/follow-up. There's a form there, and they come straight to Holly and I. They hit our Slack channel that we monitor, and so we know that you sent them. A lot of you were very upset about the link aggregation episode where we talked about LACP, Link Aggregation Control Protocol, and MLAG, and so on. You have thoughts, you have opinions. So I feel like I got something wrong in my explanation, particularly around LACP. So let's read our first comment here. This one's from Justin, and Justin says, in N is for Networking, episode 11, what's the difference between lag, MLAG, MCLAG, and stacking? Ethan said something along the lines of, LACP controls traffic on the lag. And I was debating writing in about the comment, but I happened to catch Heavy Networking being another podcast in the Packet Pushers world. Heavy Networking episode 690, LACP is not link aggregation. Now, I don't have a lot of experience outside of extreme networks environments, Justin continues, but enabling LACP is a specific extra step when configuring a lag with extreme networks gear, and I'd assume it's similar with other vendors. Okay, well, let's not respond to that comment yet, Holly. Let's just read the other ones that pile on and make me feel really bad. Okay, so here's the next one from DJ. And DJ says, firstly, great idea for a podcast. Really well done. Thank you for saying so. I like the conversational style, even though it's all stuff I think I know. It's well worth listening to, as there's always something that makes me think again about the basics, and maybe I don't know it all. I have also pointed others in my team at it for training and refreshing knowledge. Again, thank you for saying so, DJ. So now the follow-up. 2 things in the lag episode I didn't agree with. Oh,
dum,
okay,
dum,
here we go. Yeah. And DJ says lag means LACP. Ethan gave the impression that a lag means you must be using LAC, but static lags work just fine. No protocol required. I use them all the time, and they work between different manufacturers too. Secondly, you said that MLAG and a lag to 2 nodes in a stack is basically the same thing, but I'd argue that's not the case. This is a little bit of a separate thing, but we'll get there, DJ. But I'd argue that's not the case, because in a stack and even in a chassis, you have one controller active and the other in standby. So they are more like one switch and only have one forwarding table. With MLAG, you have 2 completely independent control planes working together to share the forwarding tables that apply to lag ports. Thanks again for making me think about what I do. Okay. So I said DJ, but he signs it actually David. So sorry about that. So David. Okay, we're going to answer these in a second. And we got one more comment here to read. And this one is from someone who does not give a name. We just got an email address, which we will leave off for privacy's sake. On a recent episode, N4N episode 9, high-speed Ethernet lanes explained. You may have confused people by using LACP when you were discussing port channels. While often used interchangeably, LACP refers specifically to the Link Aggregation Control Protocol, a standard protocol used to dynamically negotiate the bundling of multiple physical links into a single logical channel, while port channel is a more general term describing the resulting logical interface created by combining those links, essentially the concept of link aggregation itself, meaning LACP is the mechanism that manages the port channel creation and not the channel itself. Whew. Have we been sufficiently beaten up at this point? Well,
So I'm thinking about it, and I think I kind of understand where these comments are coming from, because
yeah.
especially the one comment that refers to that you can do static lag. I think we just went into this as lag. You use LACP as the protocol. I don't think we necessarily went out and mentioned that you can do it without it. I haven't done it without it, so I was just like, yeah, sure, use LACP. But good things to note.
So, yeah, and I'll obviously the way I phrased it was ambiguous enough or misleading, so I apologize for that. First of all, completely agree with all three of you that brought this point up. Yeah, LACP is not link aggregation. It is a control protocol that can help you establish a link aggregation group, but it is not by itself link aggregation. Exactly right. You can do a statically configured lag without LACP. I have done them, Holly. I used to run them that way. I don't prefer to do it that way. LACP as a control protocol gives you some protections because it's expecting communications from the LACP speaker on the other side of the link, and that helps make sure that your lag comes up correctly. Because it's one of those things where if you get it wrong because you crossed wires up, you used the wrong interface, you could create a bridging loop. And those are bad, as we know from our spanning tree episodes. And so, yeah, I completely agree with everybody. LACP is not the same thing as link aggregation. Somebody mentioned that heavy networking episode where we talk about that in some detail. I think Tony Burke was my guest on that episode 690, and you can dig into more details on that if you want to jump onto another podcast and get into some more details for that. 100% static lags are a thing. Yup, they work between vendors. Absolutely. LACP works between vendors. That's very common. I've run LACP between, let's say, I want to say a VMware vSphere box, a hypervisor, and a switch. I think I've done that. I've certainly done it, with other interventors. It's a standard. We talked about what the standards were on that show. I remember talking about it used to be 802.3 AD, and then they changed the standard because I don't remember what the new standard was anymore. Do you remember off the top of your head?
No.
Okay. Yeah.
Absolutely not.
So then going back to the comment from David about MLAG and a lag to two nodes in a stack is basically the same thing. So MLAG, basically multi-chassis lag, where you've got two separate switches that have their own brains, their own control plane, and a link aggregation in a stack where the brain is shared. He's arguing that those are different things. In David, in the way you described how they're different, yeah, I completely agree with you. In one scenario, the stack scenario, you've got one brain, and that brain can float among stack members depending on how you've configured it. You typically have a stack master, and then that master can be inherited as a role by other switches in the stack. But you've only got one control plane running is the key. Versus multi-chassis link aggregation, you've got two different devices that are going to share lag, but each of them have their own control plane brains. They are different in that regard, absolutely. So when I said they're basically the same thing, I'm thinking about it more from a design perspective, the way the redundancy works, the way load balancing works, and so on. Yes, I agree with you. They are different in an important way. You make an important distinction. The way I meant it was, if I'm designing this on a piece of paper and I'm looking at redundancy between physical devices, maybe how I'm bringing power and different power buses into those devices, how my links are configured, what the reliance is on various physical components. in that sense, they're the same. To be fair, it's been months since we recorded that, so if I said things on that show that are belying what I'm saying now, I apologize. But
I mean, the preface of that episode was that you've got lag, MC lag, M lag, all these different acronyms. And
yeah.
this is the exact case. It's confusing because they all sound similar. They all do similar things. But, you know, their purpose is the same. But granularly, they might have, you know, differences.
Yep, and then architecturally, David, you highlight exactly what the key differences are between the stack flavor of this and the MLAG flavor of this. That is an important difference that you bring up, and probably I should have done it, but we did it now because you sent the follow-up. So thank you for doing so. All right, okay, Holly. Here's our last question. This is on DHCP and option 55. And Justin says in N is for Networking episode 25, DHCP, someone get me an address. There was some discussion about DHCP options. And he points out a client device will provide a list of DHCP options in the request step of the DORA process. We talked about the DORA process on there, the back and forth between a client saying, I need an address, and then it gets offered, and then he makes a request, and then there's an acknowledgement. I think I got that acronym right. Yeah, but the 4-step process of DHCP, so that a host actually gets an address. Anyway, back to what Justin is saying here. A client device will provide a list of DHCP options in the request step of the DORA process, specifically using DHCP option 55 (parentheses) the parameter request list. An interesting use case, in addition to providing the client device additional information, is that the options requested can help identify the requesting device type. In other words, depending on what options I'm asking for as a client device, you can use that to kind of guess what I am. It's fingerprinting. It's called fingerprinting. So as an example, Justin says, an Aruba Instant AP asks for additional information via DHCP options 1, 3, 4, 6, 12, 15, 28, 42, 43, 60, 66, 67, and 148. Justin, I will take your word for it on that. But that would be maybe, it doesn't have to be, but it's potentially a unique thing about an Aruba Instant AP. And so if you're trying to figure out, what is this device on my wire? Well, I sniffed the packet, and I saw as it was working through a DHCP request, soliciting an address and then getting an offer and then making a request. In its request, back to the DHCP server, it asked for all of those different options to be filled. It did? Well, if it asked for all that stuff, it's probably an Aruba Instant AP. And Justin continues, a network access control system could look at the options list and use that to help provide a device fingerprint, along with things like the MAC address, OUI, which are the first 6 characters in the hex address, which tend to be assigned to a manufacturer, LLDP information, link layer. Gosh, is it device protocol? That's wrong.
I was gonna assume it was that, but I was like, I think I'm just guessing because that sounds right.
I forgot. I'm gonna look up LLDP real quick here. LLDP stands for discovery.
Link layer discovery.
Okay.
Yes, of course.
Yeah. That's where you plug into a switch, and if LLDP is turned on the device on the other end, and you're running an LLDP daemon on the switch, you'll see an LLDP packet come from that device to the switch, and it basically says, I'm this is me. And you might have things like a host name and other kinds of information that are in that LLDP packet. LLDP, and in the Cisco world, they had their own version of this called CDP, Cisco Discovery Protocol. And so Justin's point here is you can use things like the MAC address OUI, those first 6 characters of the MAC address, and LLDP and DHCP options being requested by the client to help figure out, this device is probably X. And if you know what X is, you may wish as a network engineer to make a decision about what VLAN to put that device in. Oh, it's a phone. I'm going to put it in the phone VLAN because maybe that's a thing you care about for some reason. Or I don't know what this is. I don't trust it. I'm going to put it in the guest VLAN, and it can't do anything but get the internet access and go through a firewall port, and that's it. That's all I'm going to allow it to do, for example. So, get into fingerprinting in your world much, Holly?
Yeah, a little bit. Again, from a NAC perspective, network access control.
Yeah.
It's very
It comes
interesting.
yeah, it comes up a lot for certain security
Yeah,
paradigms that some companies might want to use. They'll use some sort of fingerprinting scheme to figure out what a device is, and then figure
yeah.
out again how
I've
to
seen it.
deal with it on the network.
Yeah,
Yeah.
and I've seen it mostly for like VLAN assignments. Like, we don't want to have to manually do this. We want our guest, anything that's like a guest device or something, drop them here. Anything
Hmm.
like hospitals as well. Seen a lot in that where, if you've got this specific type of equipment, drop it on this VLAN, things like that.
Yep. Yep. Okay. Okay, last comment about this option 55 thing that Justin brought up, and thank you, Justin. You can find more information about this in RFC 2132, entitled DHCP Options in BootP Vendor Extensions. This is an old one. It goes back a ways, but some of this stuff doesn't change. But they talk about option 55 in section 9 of RFC 2132 on DHCP extensions, and specifically look at point 9.8, which is entitled Parameter Request List. It says this option is used by a DHCP client to request values for specified configuration parameters. The list of requested parameters is specified as N octets, because RFCs care about how your packets are formatted. So they're talking about octets, which is a byte. Just think of it as an octet as a byte for all intents and purposes here, where each octet is a valid DHCP option code as defined in this document. And it continues on. There's more, and it confirms that the code for this option is 55. And as Justin pointed out, there's a bunch of articles on the internet. If you look up DHCP option 55, you'll get back a bunch of articles that talk about fingerprinting and so on. So there we go, Holly. That was our first Well Actually episode. There's probably more comments in there somewhere, but again, these all came through our follow-up page at packetpushers.net/follow-up, the very best way to connect with Holly and I with your comments and questions, and we welcome them. If we get something wrong, we would very much like to get it right. And so if you flag something like that or have more information to add, we'll do another show like this at some point as more of your questions and comments come through. That wasn't so bad, Holly, was it?
No, I quite enjoy like doing these Well Actuallys. After a bunch of episodes, we can now do a little recap for ourselves as well. I'm like, oh yes, I remember the Dora. It's a nice little recap to see what we got right, what we got wrong, maybe some things that we should have clarified on, and expanding on certain topics that we
or what we
just
left
don't have
out
time
that
for.
some people think are important. Yeah,
That's always
which is
interesting.
Yeah,
Because we're like, oh, we don't have to discuss this, but if it's a big part of someone's day to day, it's important for them.
Yeah. Some little bit of housekeeping news for those of you listening. We've been doing N is for Networking as a weekly show. We're going to move to bi-weekly. That is every other week. Is that bi-weekly? I think so.
Yes.
Or is that semi-weekly? Yeah, semi-weekly would be twice a week. Bi-weekly is every other week.
Bi-weekly. I think they're actually interchangeable. It's an American thing.
I have to look. We're moving to every other week is the intention. And so if we go for a week and you don't hear from us, that's because we're moving to every other week. Maybe we'll do some other shows. Maybe we'll do some weekly shows as things come up. But between Holly's schedule and my schedule, we're busy humans. And so we're gonna go with the every other week thing with and just see how that goes. If you've got topics that you want us to cover next, like as we're recording this, Holly and I are thinking about what our next topics are. We got one topic we're working on. Someone requested that we do a mock interview. And so we're thinking about what that show might look like. And maybe we'll probably reach out to some of you in the Packet Pushers Slack group in the N is for Networking pod channel and see if any of you would like to be a guinea pig interviewee. You want us to interview you and then give you honest feedback. You got to be a little vulnerable if you're going to do that, especially if you're new to the interview process. But Holly, you've been through a bunch of interviews, right?
Yeah, I enjoy being interviewed, which is, I think, quite odd. But I've never interviewed someone, never been on the other end.
And I've dealt with both over the years. I've interviewed a bunch of people where I've been like a hiring manager and I need to bring an engineer on board. And so I screen people and screen resumes and interview them. And also been on the other side of the table where I've had to interview for a job, which is nerve-wracking. It's a whole thing. But yeah, a mock interview, I'd be happy to share from my perspective what I'm looking for in a candidate when I talk to them. And so we're working on a show there. If there are technical topics that you want us to hit, let us know. There's a million different directions we can go in. Holly, I know a fundamental area we got to cover is BGP. It's a big topic, so we got to scope that on some level. Figure out what things we need to cover. And to me, it's like I keep thinking about this horizon topic of EVPN VXLAN. BGP is another one of the fundamentals we got to get nailed down before we're able to have that conversation about EVPN VXLAN. And there'll be some other stuff too. But that's a good one we should hit. I don't know. We could talk about more management stuff. We could talk about automation stuff. We can talk about, modern things like APIs and how to query them and what that looks like and why you might care and a lot of stuff.
Yep. Everything security.
Well, yes, a whole other topic. There's a show to do about how to do security hardening for a network device like a switch or a router. How do you protect that device? Because there's guides for that. Juniper's got a guide. Cisco's got a guide to do security hardening, and they're quite involved. And there's lots of ways to think about it. There's good stuff there. Well, okay, let's close the show for today. If you do have your own ideas about what you want Holly and I to cover, please use that follow-up page, packetpushers.net/follow-up. Thanks for listening today. Send us your comments, your love, your well actuallys again to that follow-up page. Join the community Slack group that we mentioned, packetpushers.net/community. It's absolutely free. There's thousands of other people in there. They're from all over the world. Jump on in. The water's warm. And again, we do love the feedback from all of you. It is fantastic. Send more. Like, subscribe, tell your friends. And as for networking is climbing the ranks of the many Packet Pushers podcast series, and Holly and I want the show to be #1. We do. So help us out by letting the world know about this show. We are everywhere you get your podcasts, including YouTube, which if you're subscribed on Apple Podcasts or something like that, you can go to YouTube and see Holly and I chatting with each other if you would like in glorious high definition. Until next week, just remember networking isn't hard. Other people figured it out, so you can too.